Actually, we solved 15 questions. Right now, we want to solve question number 16. Pay attention to question number 16. So what's the question? How many significant figures, sigfig, if you remember, how many sigfigs are there in the following measurements, right? This number, 300 million meter per second. 300 million, right? 300 million meter per second. So how many sigfigs are there here? I told you these zeros are just placeholders. What do I mean by placeholders? They are not, let's say, considered significant figures. They are called sometimes trailing zeros. Yeah, trailing zeros, especially in integer numbers, are not significant. That's why it has only one significant figure, one sigfig, right? One sigfig. This is the answer. Number to be 25.030 Celsius. So I told you here, actually we have no problem about the non-zero digits. They are significant forever. But we have a problem actually, and we have a rule. We devised the rule for zeros, right? Zeros sometimes are significant, sometimes not. Here, this zero is significant because it's middle zero, and this one is significant because trailing zero in decimal fractions are, let's say, significant figures. So how many sigfigs are there here? 5. 5 sigfig, right? 5 sigfig. Go to question C. It's 0.00670 Celsius, right? Here I can say 1, 2, but here leading zeros are, if you remember, leading zeros are not significant because they are in front. They are located in front of the numbers, so you have to remove them. They are not significant. Only we have 1, 2, 3, 4 significant figures here. 4 sigfigs, right? What do you say about this one? D 1.004. 2 zeros sandwiched between 1 and 4. That's why they are all considered significant figures. So we have 4 sigfigs, right? And the last one, 1.305 to 0. Actually, you have to count the zeros and non-zeros because here we don't have, let's say, leading zero. Here, trailing zero and middle zero are significant in decimal fractions. That's why 1, 2, 3, 4, 5, 6 significant figures are there. Let's check our answers. Actually, A, the answer of A is 1. We solved it. B, 5. C, 4. D, 4. And E, 6, right? So we solved the problem correctly, in a correct way. Let's move on to another question. Number 18, other question. The value of the speed of light is now known to be 2.99792 and so on times 10 to the power 8 meter per second. Express the speed of light in the following ways. So this is the true value, right? This is the true value. True value, right? We want to, let's say, convert, or it says express the speed of light in the following ways. A, with 3 significant figures. Let me show you the process. Let me tell you the note about this one. It says, so we look for 3 significant figures. We have to have 3 significant figures in answer, right? Which number here? Actually, leave don't let's say focus on the power. Leave the power aside from power. Actually, just focus on the fixed number. Just focus on this number, right? The coefficient. Let's say the coefficient of the number. So we focus on this one, not the power. It says 3 sigfigs, right? 3 sigfigs should remain. That's why the 4th figure is our last figure. The last figure is the 4th figure. Let me count it from the left. 1, 2, 3, 4. So this is the last figure, right? Leave the other numbers after 7 because this the 4th one is the last digit. Drop the 7. So we drop it, but here we have round up actually. You have to add 1 unit to the penultimate number. That's why 9 becomes 10, right? 9 becomes 10. And here becomes, it becomes 10, right? But I write the 0 here, and I carry over, I write 0 here, and I carry over 1 to the 9. 1 plus 9 becomes 10. Here becomes 0 as well. And the 1 is carried over to the 2, excuse me. 1 plus 2 becomes 3. If I say the answer 3, just 3 it's wrong, right? Because it's a 3 significant figure. So how do I, let's say, how do I make it, let's say, 3 significant figure? Just by putting a point here and put, let's say, putting 2 zeros, let's say, after the decimal point. So right now, 3.00, that's why this is the, let's say, answer. It contains 3 significant figures. And just write the power as it is without changing. I told you, don't care about the power, just focus on the coefficient. Let me erase it right now. I want to read another one. The same question, but B, with 5 significant figures. I told you, whenever it says 3 significant figures, the fourth one will be our final, let's say, digit. Right now, it says 5 significant figures. So the sixth one, the sixth figure, is the last digit for us. Last digit. The last digit, 1, 2, 3, 4, 5, 6. This is the last digit, right? And I told you, the figures, the other numbers, and the power are not important. Don't care about them. So right now, this is the sixth number, right? Just drag the last one, the last digit, and we have round down actually, without any changing. Just write the other figures, 2.9979 times 10 to the power 8. That's it. 2.9979 times 10 to the power 8 meter per second. So what do you say about the 7 significant figures? So the eighth number, the eighth figure will be our last digit. Let me examine it for you. Which one is the eighth one? So we want to keep the 7 significant figure, right? 7 significant figures should remain in our calculation. But I told you, whenever it says 7, what, let's say, figure is our last digit? Actually, the eighth one, yeah, the eighth. Let me read it for you. Count it for 1, 2, 3, 4, 5, 6, 7, 8. This is the last digit, right? I drop it, but here we have round down because the number is 5. Add 1 unit to the penultimate digit. So it will be what? 4 will be 5. That's it. So these parts are not important. Actually, just write the power. We write the power, no problem. So the answer will be 2.997925 times 10 to the power 8 meters per second. Let's check the answer. This is the answer. 1, 2, 3, 4, 5, 6, 7. Let's sig fix remain. Let's move on to another question. Question number 19. How many sig fix? It's about sig fix as well. How many sig fix are there in the following measurements? I'm sure you knew it right now because let's say we solved a lot of questions and we had some specific rules for finding significant figures in a table. Actually, it's not difficult, it's easy. How many sig fix are there in the following? Here we have, let's say, an operation, 78.9 plus minus 0.2 meters. So here we have 2 probabilities. We have 2 possibilities actually. Either 78.9 plus 0.2. So separate this case actually. Here we have 2 let's say, operations, as if we have two questions. Let me separate them for you. As if we have two questions like this. We have 78.9 plus 0.2, or we have 78.9 minus 0.2. So we have two operations, addition and subtraction. The first one, actually, whenever you add 0.2 to the 78.9, the answer will be 79.1. This is the answer of the first operation, right? So this is the answer. The second answer, actually, the answer of the second operation is, subtraction. The answer of subtraction is 78.7 meters, actually. Both of these answers actually contain what? Both of these answers contain, let's say, three significant figures. That's it. It says, so either the answer is 79.1 or 78.7. Therefore, in both cases, there are three sig figs, right? Because I told you, non-zero digits, without thinking, non-zero digits are what? Are significant. Without, let's say, so we have a problem about the zeros, actually. We have no problem about non-zero digits because they are always sig figs. B, 3.788 times 10 to the power 9 second. How many sig figs are there here? I told you, don't care about the power. Just focus on the, let's say, coefficient. Don't care about the power. So coefficient has what? Has 4 sig figs because all of the numbers are non-zero digits. What do you say about this one? It's like the first one. So we have 3 sig figs because all of the numbers are non-zero digits. What do you say about this one? We have some zeros within the number. Some zeros are located in front of the digits. I told you these zeros are called, let's say, leading zeros. Leading zeros in decimal fractions are not sig figs. That's why neglect them. Just let's say mention the non-zero digits. 2 sig figs other in this number. Let's move on to question 20. Carry out the following arithmetic operations. Find the sum of the measurements, right? After that, we do the operation, and after that, either we round it, let's say we round them up or down, based on the, let's say, based on the situation, based on the answer, and we obey the rules that we got it in the previous lectures, and we had it in a table, right? So the first one, find the sum. It says, find the sum of. So we look for the sum of these equations, these numbers. We want to add them together, add them up together. After that, you find the answer. This is the answer, actually, 796.53 gram, right? We want to, let's say, round it. But here, we have, let's say, summation, or addition. In addition, what's our rule? In addition and subtraction, which of these, let's say, figures, let's say, has least decimal places? Decimal place, not sig fig. So here, this number has no sig fig, has no decimal places. Excuse me. What do you say about this one? It has one, so it's not. It can't be the least one. Till now, this is the least, the number with the least, let's say, decimal place. What do you say about this one? It has 2, actually. It doesn't count. It doesn't count. What do you say about 2.5 gram? It can't be because it has let's say, decimal places, 1 decimal place, actually. But here, this number has no decimal place. That's why the answer should contain no, let's say, decimal place, because we compare it with this number. So this is the answer, right? 796.53. So how can I change it actually? How can I round it? I told you 3 figures should remain, yeah? 3 figures should remain here based on this number. We copy, let's say, this number. As if you copy this number, you obey the, let's say you copy the number of decimal places, not the value of the decimal, not the value of the number actually. So here, these numbers, let's say, remove from the figure, but here the number after the 6 followed by what? 6 followed by 5. That's why 796 should round up, to 797 second, right? B, find the quotient. Quotient means answer. Find the quotient of 3.2 divided by 3.563 second, right? You want to, after calculation, actually, after you divide 3.2 by 3.563, actually, you find this number, right? You find this number. Here we have division, yeah? We have division. In division, the rule is different from the subtraction and addition. Division and multiplication have the same rule. Here, we don't say number of decimal places in division. We say number of sig figs, right? So the answer should contain what? Should contain the decimal, should contain the sig figs as what? As the number with the least sig fig. As the number with the least. Which one has the least sig fig actually? 3.2 or 3.563? Of course, this one, yeah? 3.2. So the answer should contain only 2 sig figs. Here actually it contains 2 sig figs, but based on the rules of rounding, this is our last digit. I drop it. I add 1 unit to the 8, and it will be 0.9. If I write 0.9, let's say the answer is not right because the number with the least sig fig is 3.2. At least we have to have 2 sig figs, 2 sig figs. But here we have 1 sig fig. But we have a solution here. You can add, let's say, 0 here, and this is the answer. So we have round up to, let's say, as well. Let's move on to another one. Find the product of 5.67 millimeters multiplied by 3.14 actually. Pi means 3.14, right? 3.14 here. Both numbers have the same, let's say, sig figs. Both numbers have 3 sig figs. So the answer should contain 3 sig figs as well, because this is the rule of, let's say, multiplication. The answer is this, 17.80, yeah, 17.80 millimeters. So it can't be. We don't accept it. So what shall I do? We have to, let's say, remove this one in order to get, let's say, 3 sig figs actually. And the answer will be 17.8, and the situation is rounding down. The last one, find the difference. Find the difference means subtraction. We have subtraction here. Difference of 27.54 second and 3.8 second. So you have to subtract this number from this one. You have to subtract the smaller number from the larger number. After subtraction, actually, you find this number. This is the answer. And what's the rule for, let's say, subtraction? I told you subtraction and addition, they have the same rule. We focus on the number with the least decimal places, not the least sig fig. So which number involves least, let's say, decimal places? This one, of course, because it contains because it contains only 1 decimal place. After the point, we have only 1 figure. But here, we don't accept this one, right? Because after the decimal point, we have let's say, 2 decimal places. The answer should contain 1 decimal place. This is the answer, right? It can't be actually. We don't accept it because I told you we have to obey the rule. That's why we have two, let's say, decimal places. You have to neglect the last one, drop the last one, and just write the rest number, 23.7 seconds. So we had round down as well. About the other questions, I want to finish our lecture here. Thank you very much for watching this video.